Okay, I'm going to do a short video on getting started with the STM32 Nucleo. This is a L3. Okay, let me share the camera. Okay, this is Nucleo-L053R8. Okay, as you can see in the video, this section here is for the embed, and this section here is for the Arduino interface. So you can use both Arduino or embed programming. This section here is the breakout section of the STM32L053R8 chip, and this section here is actually the ST-Link programmer part, so you do not have to buy an additional programmer, and the interface using the micro USB. Yeah. So to program this IC, what we're going to use is we're going to use the tools from ST Microelectronics, which is called the STM32CubeMX, for the pin configurations, clock configurations, and you generate the initialization code. And then we're going to program the firmware using the Microvision Keil. Okay, so the first thing we need to do is go to the STM website. So click here, www.st.com. We need to download the driver for the Nucleo-64 board. So we call this ST-Link driver, and it's actually a STSW link 009. Click on get software, and accept license agreement. You can type in your name and the email address, or you can log in or register. So for my case, I've already registered an account, so I can use my account to log in. It takes quite some time to download the file, so I already downloaded beforehand. It's let me open the folder. I've already downloaded in this folder. It's in the zip file. So we got to click on the DP install. Mine is 64-bit, so double click on this, and you're able to install the driver. And I already did that beforehand. Okay, the next one is you need the STM32CubeMX. As I mentioned, this is for the pin configuration, the clock configuration, all the initialization, plus the middleware and other libraries. So okay, so you can enter your email address and password, log in, and you will download. And I've already downloaded to my folder. So it's STM32CubeMX. Mine is version 6.0.0. And then the last software from the ST is the ST32Cube program. Sorry, STM32. It may take a while. Okay, this is the one. Click on this and get software. Accept license agreement. Key the information, or you can enter your username and password. And you install and you save it in your folder. Yeah, this program is meant for downloading your firmware onto the IC. However, today we're going to use the Keil microvision for programming of firmware, and the Keil microvision actually do have a download button that it can be used to download our firmware onto the microcontroller. So you go to the Keil. Click on downloads and select MTK ARM. Because the board that we're using is the STM32L053K6, it is actually ARM Cortex M0. So key in all the information. Okay, your name, email address. You must use a valid email address. And then you submit, and then you're able to download the file, which I already did over here. It's about close to 900 megabytes, so it takes quite some time. So all these files I've downloaded, and I have to install one by one. The first I will install is the SD-Link driver, then followed by the QMX Qt Programmer, and then the QMX. This is the Qt Programmer, QMX, and then Keil. Okay, because Keil you need to do some configuration. Okay, so let me go to the Keil. Okay, in Keil you need to activate the license. So you go to File, License Management. Over here I already have the license. Yeah, but for you, you have to get your license, which is a license ID code via internet. So click on this and OK. Okay, so this is the computer ID that is generated for you. So your license will be used on your computer. And then this is optional, your PC description, your name, and a valid email address. This must be a valid address. Select a country, company, your company, phone, etc. Okay, the thing that you need to key that you don't have is the product serial. So if you have a license, you can buy the license, or you can use a free version. There's a trial, 1 month trial. However, for the STM-L0, G0, and I think it's F0, they comes with a free license. So you can get the product ID from the internet. So let's search for the Keil license. So Keil PSN STM-L0, STM32L0. So in this page, they will tell you that we are using the STM32 F0, G0, and L0. You can use the product serial number from here, which is a full license and is free to use. So use this one and key in where is it? over here. Okay, so you copy and paste it here, and then you register, key everything you need and submit. After that, they will send you the LIC code to your email address. LIC code into your email address, and you copy and paste over here. Okay, copy and paste over here and click add LIC, and then it will tell you that it expires about 10 years. I think it's about 10 years license, and then you click close. Okay, so now we start our first program. So you may close this, and we start with using the QMX STM32QMX. Okay, we can, because since we are using the Nucleo board, so we can access to board selector. If you are building your own board with the IC, you can access to the MCU selector. So we use the board selector. The disadvantage of using these tools is that you have to be connected to the internet. Takes a while. Okay, to select our board, it's a Nucleo-64 and the IC is STM32L0 and it's L053. Click start project. Initialize all peripherals with the default mode, yes. So it's a graphical method to configure your ICs, and when we use the default mode, all the pins that is already connected on the board has been configured for us. So I put side by side so that you can have a clearer look at the configuration. With this maximum, I can reduce the size. No, smaller. No, I cannot. Okay, so this is okay. So this is my board. Okay, and the IC is here. Okay, we have this is, let me plug out the USB first. Okay, this is the LD3. LD3 is connected to, where's my LD3? Okay, let's look at LD2 first. LD2 is over here. LD2 is connected to PA5, and this blue button, user button, is connected to PC13, and we have reset button connected to this reset pin. These two pins are used for debugging, and these are for the UART, which we are not going to use for this practice. Okay, and you notice that I think this LED is always turned on when it's powered up. Okay, so it's not connected to the microcontroller. Okay, if you notice our board here, this is a low speed clock. Okay, this is I think is, yeah, this is a low speed clock, and then the crystal is not populated on this board. Okay, the crystal actually is over here. So since this is not used, we can choose this to select reset state. You can use it for GPIO, general purpose input output pin. Okay, so that's it. That's our setup. Next we configure our clock. So we have a 32.768 kilohertz low speed clock connected, but we're not going to use for this exercise. The input high speed clock is not connected, so we use the internal clock, high speed internal RC clock. Okay, all the frequency are only 2 megahertz. We can change this to, let's say, 16 megahertz to make it faster. Choose OK. So we change all the configuration for you automatically. Since the high speed internal is 16 megahertz, so it's going to connect directly to the 60 megahertz. It's not going to use the phasor loop. Phasor loop can help to increase the speed of the clock. Let's say use 32. Then we use the phasor loop. So it passes through the phasor loop instead of select the phasor loop clock. So we may not have to use the phasor loop, so we use 60 megahertz. And if we choose the path, can choose the path using the high speed internal clock. Okay, so over here in the project manager, let's change our location, maybe the project name to let's change it to maybe blank, not say blank, test. Okay, just a test, and test 01. And we are going to use the MTK arm. This is the Keil microvision Keil. Okay, what else do we need to set? And generate the code. Let's open the project. Okay, so this is a project, and we look for the source code, which is placed under the application user in the main. So this by default, it will show you the interrupt. Okay, we'll go through the other .c files next time. For today, it's just for the beginning. Okay, so by the way, the code is generated. You can close the QMax if you want, because where the code is generated is placed under the folder here, and you notice there's an MX project. This is the microvision Keil project. You double click this and it can go into the Keil. Okay, then the source code is placed inside the source over here, main.c. Then the header files is placed under here. Okay, the drivers and libraries are also here. Okay, sorry, the program for the Keil is placed under here, microvision project, which is under the MTK arm. So when we close the microvision Keil, you can open the project from here. So go to your project folder and MTK arm and double click on this, and you shall open the project. Okay, and if you have some changes to the initialization code, because let's say you want to change the clock frequency, you can go back to here, the MX. Just double click on this, you go into the QMX. For example, in my Keil, let's take a look at the clock configuration. Okay. Okay, we see from the clock configuration. Or how about we change the Gpl pin name? So right now the Gpl pin for the green LED, okay, the button is called a B1. Okay, we can change the name. We can change the name to let's say B2 instead, and we click on generate tools. We click on the generate tools, and we can close. And when we open the Microvision Keil, the file has been changed. We want to reload, click yes and yes. It takes a while for it to reload. And when you scroll down, you see the name has been changed to B2. Okay, so now I change it back to B1. And generate code. So we change back to B1. Close. And yes. It takes a while to upload. And we scroll down. Now it's been changed to B1. Okay, now let's do a simple code here. So in my main, okay, and one more thing is that when you want to modify the code, you have to do it between like say user code begin these private variables. So your variables we have to put inside here. Otherwise, when we do the QMX, if you overwrite your code, if let's say it's not inside between the command here. So for our main code, we have to write our code under here, user code begin 1. This is the first one, or you can put it under here, user code begin 3. But if you put outside here, let's say it's outside the user code, let's say you put it here. Once you do the QMX generate the code, you will overwrite whatever you have programmed. So to be safe, we have to put our code inside here. So we do a simple code. So we press a button, it will toggle the LED L2 switch. Okay, so let's say if we use a whole library Gpl pin, the pin is the button is B1. So we call this B1 Gpl port and B1 pin. Okay, we read this pin. So if this pin is low, means it's pressed, then you will toggle the LED LD2. So we put here if. Okay, then if it is low, we have to write the pin using the whole library, like Gpl like pin. This is LD2 Gpl port, LD2 Gpl pin, and we want to write it in to reset toggle Gpl pin, Gpl pin toggle reset. I can't remember what is the toggle. I think it's toggle pin. So instead of right pin, we toggle. Let's confirm. GPIO toggle pin. Yeah, toggle pin. So we have LD2 port, LD2 pin. Okay, is it done? Okay, forget one bracket here. Okay, let's save it. Click on save, and we use the build. There are two build and rebuild. So we use the build. If let's say this is the first time you're building, you'll build all the libraries that's needed. Okay, let's say you already built one time and change the code. When you press the build, you will update all the changes that you have made instead of rebuilding the whole code, including the libraries. It takes a while. Okay, 0 errors, 0 warning. And then we use this button for the debug. Okay, this because I forget to plug in the USB, so click on OK. Okay, let's try again. Click on the button. Okay, not a genuine ST device abort connection. Okay, this happens because you need to go to the project option, and you have to go to debug, and under the settings for the ST debugger, you choose the connect, choose with pre-reset, and click OK, and OK, and you build again, and now you can do the debug. But before that, let me open the camera. Okay, so I've already connected my Nucleo board to via the USB to my PC. Okay, let me swing down a bit on the Keil so that I can see both the actual board and the code. So I click on the debug. Where is my debug? Okay, the debug button. So it will compile, it will download the program to my board. Okay, so I can close already to my board. Okay, and I don't need this. And okay, start from beginning, and I click. This is a run, and this is a reset. Start from beginning. So we click on run, and now it's running. So if I click this button, it will turn the LED turn on. The LD2, which is a green LED, turn on. I press again, it will turn off. Okay, it's quite difficult to turn it off because I do not include the debouncing. Okay, let's include some debouncing here. I have to stop the debugging and go to the code here. Okay, let's do some debugging. So delay, let's say we put 100 milliseconds. The delay function is for the whole delay is for 1 per millisecond. Yeah. Save all files, compile again. Click on debug, and we run. Okay, then I click on the user button again. Still not working well. Let's see, what can we do? Okay, we can put the while loop here so that it can always pause here until when the hand release. It's up to individual what you want to do. So this is code. So when I press, and then if I don't release, okay, even I release, I can have another debouncing again to make sure. So this time around it should work. Okay, save, compile, okay, debug again. Okay, let's run it and we see button. So the green LED is here, and each time I press, you press one time, you turn on, press another time, you turn off. Okay, so the debouncing works. Okay, so that's it. Thank you for watching the video.